AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 3: Data Preprocessing. Data preprocessing. Essential step to prepare data for mining. Involves data wrangling, cleaning, modifying, restructuring. Data preprocessing is the second of the 5 major steps in data mining. Welcome to Lesson Chapter 3, Section 5, Reducing Dimensionality. In this lesson, we'll explore what happens when datasets have too many variables, why that creates problems, and how dimensionality reduction helps simplify and improve analysis. By the end of this lesson, you will be able to understand the curse of dimensionality and why it's a problem. Explain why having too many variables makes data harder to work with. Know what dimensionality reduction means. Describe the basic idea behind principal component analysis, or PCA. And recognize when and why to reduce dimensions in a dataset. Let's start with the curse of dimensionality. As the number of variables increases, the data becomes more complex. The space that the data occupies grows exponentially with each new variable. That means data points become more spread out and sparse, making it harder to find patterns or relationships. Statistical models and machine learning algorithms often perform worse in these situations, because the data density is too low to generalize effectively. And from a human perspective, we simply can't visualize or think in more than 3 dimensions easily. To understand why this is difficult, imagine a one-dimensional dataset, for example, people's ages represented along the line. That's easy to visualize. If we add a second dimension, say income, we can plot age versus income on an XY graph, still manageable. Add a third dimension, maybe education level, and we can picture a 3D scatter plot. But once we move beyond 3 dimensions, visualization breaks down. We can't really see or imagine what data looks like in 5, 10, or 100 dimensions. That's where computational techniques become essential. So, what is dimensionality reduction? It's the process of reducing the number of variables while keeping as much of the original information as possible. Instead of working with all the original variables, we create a smaller set of new variables that summarize the data effectively. These new variables are often combinations of the originals. Reducing dimensionality makes data easier to analyze, visualize, and model, especially when you have a large number of correlated variables. Concept of dimension reduction: 2 dimension projected down to 1 dimension. A common technique for this is called principal component analysis, or PCA. Although PCA is based on linear algebra, using things like eigenvalues and matrix decompositions, the concept is straightforward. PCA looks for patterns of variation in the data and creates new axes, or directions, that capture the maximum amount of variance. Each principal component is a combination of the original variables, arranged in a way that explains as much information as possible with fewer dimensions. The first component captures the most variation, the second captures the next most, and so on. Instead of deleting variables, PCA combines them mathematically into fewer, more meaningful dimensions. For example, if you have 10 survey questions that all measure similar ideas, PCA might combine them into 1 or 2 components that summarize the main patterns and responses. You lose some detail, but keep most of the meaningful information. When is dimensionality reduction useful? It's especially valuable in areas like bioinformatics, genomics, and image recognition, fields with massive datasets containing hundreds or thousands of variables. It's also used in exploratory data analysis, to make visualizations simpler, or in machine learning, to improve model performance by reducing noise and redundancy. To summarize, the curse of dimensionality describes how too many variables make data sparse, complex, and difficult to analyze. Dimensionality reduction solves this by creating a smaller set of combined variables that preserve the essence of the data. Principal component analysis is one of the most common ways to do this, turning high-dimensional data into a more manageable form for analysis and visualization. That concludes Lesson 3 to 5, Reducing Dimensionality.